Okay, so for this next part, we will be focusing on day 2 VNF operations. So if you see the wiki, there are 3 sessions, this one and 2 more, but the slide deck is basically the same for the 3 of the session. So it's just one thing after another. So for this part, I would ask you to copy some examples that we had in the virtual or in the management VM that you are using for the Hackfest. So you can copy that folder into your home directory. And there are basically 2 folders inside. Make sure you can see them. One is the base package that we will be using. And the other one is the result or the package is the same one, but with the relation implemented. So for all of you, I would recommend to start with the base package, do the changes there while I'm going to explain it, and then use that instead of using the one that is already finished. Okay, so you can do that now. I will wait 1 minute for that for all of you to do that. Let me paste also the command in the chat. If you have any problems, please let me know. I pasted the link in or the command in Slack and here in the chat. Also, I understand that you all have the Magma orchestrator installed or deployed um, Helm, and you don't have anything else there. So if you have, apart from the Magma orchestrator, anything else, please remove that network service so we have space for and resources for this session. Okay, I will continue now with the presentation. So basically, as we said before, telcos will have history and won't change overnight. And basically, OSM needs to be effective in the integrations of different network functions. So this slide shows the summary of what we are going to do in this session. There are two VDUs, let's say VMs that we are going to deploy in the VM in OpenStack, and the 2 components are one, the Magma virtual EPC, and the other component is the eNode B with the user emulator there. So and one of them can be modified, so we can use a native charm for that, and the other one cannot be modified, so we use a proxy charm for that. This is the picture that you have probably seen in previous sessions. And basically, the two VDUs that we will be deploying here are the Magma Virtual EPC. That image is the one that cannot be modified, so we will use a proxy charm for that. And the generic Node B and user emulator, that one can be modified, so we will use a native charm for that. I will be showing also the code for the charm, so you are aware of how to deploy or how to develop and how to do your own charms. So let's start it with let's get started with the Magma Virtual EPC. This one, as I have already mentioned, has a fixed VM image that predates OSM, so it cannot be modified. That's the name of the image. And this image has already Magma installed. Requires a proxy charm because the image is static and is not an installable application that we can then manage. So for the proxy charm, we will implement a different set of actions that are well, adding the network, the gateway, adding hosts, the test subscriber, and so on. So these actions are already implemented in the examples that I gave you, but I will be showing the examples so you can add your own actions if you want, and I'm going to show also now the descriptors. So in this case, we are working with this case. We have OSM, we have the VNF image that is the Magma virtual EPC, and the proxy charm will be deployed in LXD, so in separately in another instance. So this is the VDU configuration that or the YAML that we need to add in the VDU configuration for the Magma virtual EPC. So first of all, we state there that the UU charm that okay, sorry. Okay, the Magma orchestrator, you can still have it if you have that deployed. Perfect. Don't delete it because we are going to be using that orchestrator. So and if you have deleted, then deploy it again with the same instructions as in the previous session. So continuing to the slide, we state there the UU charm name. That charm will be in the charms folder, as I will show later. Also, we state there that that we will need SSH access to the VM. So that will basically do some or perform some actions that will get the SSH key from the proxy charm and insert that in the authorized SSH users to the VNF, so that the proxy charm can log into the VNF without any issues through SSH. Okay, and basically then we will define an initial config primitive. Those are the primitives or the actions that will be executed one after another once the VM is deployed. And then in the config primitives, those are day 2 actions that we can execute afterwards. So for the initial config primitive, basically there's the first action, or the first action has to be named config, and that's basically to let the proxy charm know the SSH hostname and the username that it has to use. The SSH password in this case wouldn't be needed because as we specified before that we need SSH access. With that, we are provoking the OSM to inject the public key to the VM, so that you don't need to specify the password, and you can log in or SSH into the machine using keys instead of the password. So yeah, basically that's it. And this is the first configuration primitive that has to be created for all proxy charms. And then we will basically add a set of actions. And you can also see that there's a sequence number that will let OSM know in which order are these actions needed to be executed. So basically, well, the actions are very specific to the workload. Honestly, I'm not aware of the insights of what those actions are doing, but basically it's to reset the ID, to add the network, so it registers to the Magma orchestrator, then adding the gateway and the test subscriber for the user emulator, and adding the host and restarting the Magma service. And then for the config primitives, we have added here adding the gateway and deleting the gateway, and also resetting the ID and the Magma service. So now we will be diving into the charm code, and for that I will share my terminal. If there are any questions until this point, feel free to ask.
Hi, Nishank here. So all the primitives which you just showed, config primitives, right? The actions would be defined inside the charms, right? Would it be? Is it a right understanding? The actions like the actual code, right?
Yeah, exactly. I will show something that will clear that for you. So,
okay. Thanks.
Okay. Can you see my terminal?
Yeah.
Okay, I will make this a bit bigger. Okay. So basically, if I go to this folder, that is the one that I copied from the folder I told you before, I have both the base descriptors and the relation. So I'm going to show first the base one, okay? And okay, let me go to the VNF. Okay, so basically, first of all, I'm going to show the VNFD descriptor, okay? So in the VNFD descriptor, we have two BDUs. This one, that is the inode B, okay, this one, and that I haven't explained that yet. And we have this one that is the VDU for the Magma virtual EPC, the A gateway, okay, this one. So here, in this part, from here to the bottom, is what I have added. It's exactly the same as in the slides. And basically, these actions, the initial config primitive actions and the config primitives, these are the ones that are exposed to OSM, but the implementation, the code of each one of the actions is implemented in the chart, and is what I'm going to show right now. So if I go inside the charms folder, I will see the inodb and magma gateway folders. Okay, this thing can be removed, the inodb sheet, we don't need that. And well, we will start with the magma gateway. So here you can see several files, and I'm going to show the most important things right now. That basically these folders and files are what compose the charm, and I'm going to start showing the metadata.yaml. So here we have basically, well, as the file says, the metadata of the charm. We specify the name, the summary, the maintainer, description, and so on. We also specify the series, the list of series that this charm can be deployed on. I have put Genial and Bionic, for instance. And here also we have the room for specifying the relations that we need to implement. So this relation has to be implemented in all proxy charms if you want, but this is needed for the HA proxy charms to work. So if you want to have the charm in HA, you need to implement this relation. Okay, and this is for later, for when we are going to add another relation, but I will explain that a bit later. Also, we have the config.yaml that basically these are the configuration parameters that we can specify. The ones that are really needed are these three. Well, the first two, if I'm honest, because this one, the SSH password, can be avoided if we use if we specify in the VNFD that the SSH configuration is required, because in that case there's a procedure that OSM will do to get the public key and inject it into the VM, so that you don't need you don't need to put the SSH password. Okay. Okay, so let's continue. Okay. Then we have the actions. Okay, that basically here we can see the list of actions that are implemented in the charm. Okay, and there are some actions that have parameters, some others don't. Okay, but basically here we state the name of the parameters, the name of the action, and the type of the parameters. And if we want, we can set the default value for the parameters. Okay. Okay. Great. So now we are going to go and show the actual code of the charm. Okay. So here, let me zoom out for you to see. As a well, in a high-level view, what the charm code is like. Basically, if you are familiar with Python, this is just Python code, okay, that has different functions for different events, and just that. So it's really simple, and I'm going to show you now how to well, the details of the implementation, and so that you can learn how to build your own charms. So before continuing, I would like you to...
Sorry, David.
Yeah.
Can you make the font a little bigger? Because I think people can't really see the code. At least I'm having issues, trouble.
Okay, yeah. I wanted to show a high level to see that there are not that many lines of code, and that is Python.
Okay.
But yeah, I will go now a little bit.
Thank you.
Also, could you please share the link for the charm OSM repo in GitHub, the one that has the SSH proxy charm library?
Yes, I can do that.
Okay, thank you very much. Okay, so let's wait for Dominic to share that. But basically, while he's doing that, I just wanted to say that we built this one library that basically avoids you from handling the same events that needs to be handled in all proxy charms. So in case you want to deploy or develop your own proxy charm, now you should only pull this dependency and inherit from that base class. That will let you well, that will let you to avoid having to do a lot of things that are needed. And also, HA proxy charms will be available for you if you implement this, because we handle there all the different actions that needs to be implemented, so the HA proxy charms are supported. Okay. If you want to know more about how that is done, how can you use that, the README file of that repo can help you out a bit, or just ping me if you have any questions. But this example should be enough to get started with your own proxy. So basically, here we have included the new operator framework in the dependencies of our charm, and this base class from charms.osm.ssh proxy, and we have inherited from there. So basically, I'm going to explain now this part of the code, the constructor of this charm. Basically, there's one thing that is the stored state that basically helps you out with storing data, key value data in that variable, and that data will be shared between different events. So if in the install you want to state that the charm has been installed, then you can add one variable here in the stored state to say installed equal true. And then in another event, for example, when you are related to or relating to another application, you can check if the charm has been installed or not in that different event. So that's one thing that is very, very useful. And then we listen to charm events. So as I said before in the first session, the charms handle different life cycle scripts. Okay, so there are some events that happens when you install the charm, when the charm is starting just after it is installed, and when the configuration is changed. There are also a couple of more events that we haven't added here because there are no necessary, but you can add also the upgrade charm event and the update status event. Okay, so basically here we are saying self.framework.observe. So we are observing those events. And for example, in self.on.config change, we are calling self.on.config change. Okay, that is right there. So each event maps with one function that is defined in the chart. Okay, so when the config has changed, then we call onConfig changed. When the install event is set, let's say, then we call self on install, and the same thing for the start event. Okay, let's continue. So this list of observes are to observe the events that are associated with an action. So for that, you can probably see a pattern here that is basically that you put, for example, in the first part, self.on. the name of the action _ action. Okay, and when that action is executed, then we will call the function on add net action. Okay, and the same, basically the same thing applies to all the actions. Okay, for the add gateway, reset ID, add hosts, and so on. Yeah, I don't know if you have questions until this point. Okay, so now I will go explaining one by one all the different events or functions that are called when the events are raised, and basically this one is for when the onConfig change needs to be handled. We put here all the things we want to do. Basically, in this two, we don't have to do anything because we don't have to install anything or whatever. But we are calling the superclass, that is the SSH proxy charm class that we have inherited from, because in that class we are doing some stuff that we need to do for the HA proxy charms to work. So just it's all explained in the documentation of the GitHub repository that this is needed. And also, for example, in the onStart event, we can see here that we are calling the superclass, but then we are checking if we can. Well, this is one function that is exposed by the superclass, but all these things are explained in the documentation of the repo. But basically what we are doing is if we have verified the credentials, then we are going to get some IPs of the VM that we will need afterwards to send those through the relation. But I will explain that later. Okay. Then we have the implementation of the different actions. So in this action, well, the VM, the Magma Virtual EPC VM, basically has some scripts that we need to call well, in order to perform the actions that we want to make. So in this case, basically what we are doing is I'm going to explain one action, and then the rest of them are the same, but calling different scripts, let's say. So basically, we are detecting here if the unit is the leader, because when we have multiple units of a proxy charm of the same application, we only want the leader, the one that is the leader, to perform all the actions. If that goes down, then another unit will pick up the leadership. But we want to make sure that that only the leader unit performs the action. Then we get the action parameters with this. Okay, so to this function, there's one event object that is passed, and we can access the parameters with event.params, and then we put the name of the parameter that we want to get. So basically, we get all those two parameters in this case, and the superclass lets you or gives you a proxy object that basically has everything you need to perform commands via SSH, okay, to the VM. So in this case, well, I'm not sure why the attempts are needed in this case, but this is not important. The important thing is this, that you can basically execute proxy.run, the command that you want to execute, and this basically will perform the action and so on. And then you can set the result of the result of the event like so. Okay. Okay, and then well, in this case we are stating we are setting the registered state to true. So to say that we are registered to the Magma virtual, well, to the Magma orchestrator. Sorry. Okay, and then the rest of the actions are very similar. So just calling different scripts or different commands. Okay. Basically, that's it regarding the Magma Virtual EPC. Is there any question? Maybe this is a bit hard. If you are seeing this for the first time, if you are already familiar, then it won't be that hard. But feel free to ask any questions. Okay, so let's continue. Okay, so let's continue. You can see my slide, right?
Yes.
Yeah. Okay. Okay, thanks. So now I will be showing the inode B and user emulator. In this case, we are working with this use case in which we can deploy the native charm into the same VM. Okay. The image of this VM is based on Ubuntu Bionic, and that's the name of the image. And the image has already installed the inode B and user emulator. This is a native charm, and we will be adding several actions to the or relations to the actions to the charm. If you see, the register and unregister actions are crossed out. That's because in the past we executed or we implemented actions to register the inode B to the Magma virtual EPC. But in this case, this time, we are doing that action automatically through a relation, and I will explain that afterwards. So just to see it a bit clearer, OSM will deploy now the VNF, and the charm will be in the same workload as the VNF. So in this case, in the VDU configuration, we will say that the UU charm is the inode B, and the proxy, we set the proxy key to false because it's not a proxy charm. By default, if you don't specify anything, it understands that the charm is a proxy charm. Then we are setting the SSH access that is required, and the default user is Ubuntu. And we are only adding one initial config parameter as day2 to remove the default gateway. We do that because we want to make sure that the user emulator goes through the Magma virtual EPC rather than going through the management network. That because if the traffic goes to the default gateway, then you already have traffic and so on. But we want to emulate how it goes through the Magma virtual EPC. So we will perform that that action, and then in the day2 configuration, we will implement the attached user emulator and the detached user emulator. Basically, we need the attached user emulator to the user emulator to be attached to the inode B, okay, to the radio. Okay. So now let me share a bit about the code of this part. Any questions? Okay. Okay. Also, if you have any questions, you are a bit shy, don't feel free to ask me in Slack anytime or to my email. I'm glad to help with whatever you need with regarding charms and all this. Okay. So I'm going to show right now the VNFB. So this part is the VDU for the inode B and the user emulator, the part that I have been talking about. And basically, this is what I have added in order to include the actions or the charm and so on to the VNFD. So yeah, well, the same thing as I explained right now. Okay. So if I go to the terms folder, I can see that the inode is there. That's the same name as we have put in the Juju charm key. So the structure seems likely similar to the previous one. So we are going to go a bit faster this time. So in this case, we have put the different name to the metadata and well, the summary, maintainer, description, series. That's the same thing as before, just the metadata of the term. Then for the config, we don't have anything. It wasn't necessary to add anything here, so we have. It's just an empty dictionary. And for the actions, we have the three actions that we have implemented. The remove default gateway, detach user emulator, and the other one that is for attaching the user emulator. Okay. And then in the source charm.py, we have the code of the charm. So let me zoom out just for you to see the number of lines that the charm has, just less than 200 in total. So it's just this for all the implementations of the actions, the operations, and everything for the use case that we are covering here. So let's zoom in a bit. In this case, we have inherited from the charm base class that is part of the operator framework. We did the exception of inherit from another class in the previous example, but that's basically something needed only for proxy charms that are SSH based, so that communicates to the VNF through SSH. For the rest of the charms, you have to inherit from this one. Okay. And in fact, this one is much simpler, I would say, well, in my opinion. Okay, so basically, we are here, we are setting the state is started to false, okay? This is same as before. We are instantiating an object of stored state to share that between the, well, to share the data there between the different charm events. And the important part is this one, okay? So here we do exactly the same as before. So those are lifecycle scripts. So in these events, config change, install, start, and upgrade charm, we will call these functions on config change, on install, on start, and on upgrade charm. And then for the actions, the same. Just it's the same thing as before. So in this case, we are not doing anything, well, almost anything in those actions or in those events, and just in the on start event, we are setting the unit status to be active. We will see that afterwards when we execute some Juju commands. Okay. Also, this is the implementation of one action, let's say, when the relation to the Magma virtual EPC is set. I will go and explain this afterwards in the next session, okay? But basically, we are implementing the actions with Python code. There's nothing different that what I have previously said before, okay? Just one curiosity, it's not really important, but basically the commands that we need for attaching the user emulator, for instance, this is a command that that never finished. So it's not like executing a command and it finished and just it. It's a daemon, so it's continuously being executed. So I basically implemented this function that is run daemon in Python, which basically opens the sub process to execute the command, but never closed it. But it's never closed. So the action is this code is finished, but the process is in the background still. Okay, so we have finished this part. Any questions?
I have a question with the difference between when you said before that proxy terms are meant to be used with images that are not that cannot be modified, but I think I don't understand exactly what you mean with can't be modified. So what's the difference between an image that can be modified and another one that cannot?
That's a very, very good question. Thank you for raising that. So basically, you can think of well, the best example for an image that cannot be modified is, for example, the PNF, for example, all PNFs or that are physical network functions cannot be modified because the physical appliance is already there. It's a router. You cannot install Python, for example, in that in a PNF. Okay, and there might be some virtual images, some VNFs that use one image that is very specific. Okay, so in this Hackfest, we will be using a various router that is virtual, but and it uses one image, but the image cannot be modified. It's a very specific software that cannot be that you cannot install Python there and execute commands and so on, and install packages, etc. Okay, so
but
you
in that case, sorry. I mean, in that case, if you can do anything on there, the code executed on the proxy term can execute something inside that machine, but you can't access. It's the point that I can't understand.
Okay, it's fine. I will. This will be a bit more clear for you tomorrow when we show the BIOS router and how we configure the BIOS router with the proxy channel. But basically, this BIOS router supports some actions that are, for example, to add some IPs to the IP tables or to the routes and so on. So you can let me think about a better example. For example, you can have one router, one image of a router, and this image can expose one REST API, for instance. So in this case, the proxy charm will perform actions calling the REST API exposed by the VNF. But we are assuming that in this case, for example, that you cannot install Python or packages from inside the VM. So I don't know if that is a bit.
Oh yeah. I understand now. Okay, that example. Thank you.
Okay, you're welcome. And feel free to ask these sort of questions because it's the best way to learn. And maybe I don't explain something very good or very clear, and this can help others understand it. Okay.
Hey David, just I seem to have missed it. You told the function of state is equal to stored state. It was to share the states between the VNFs. Can you please come again on that?
Okay, no, it's to store to share data, for example, or variables between events. So imagine, let me do one example, okay? Okay, in this case, I'm going to in the self default, I'm going to add here one new variable. This will be, for example, install, okay? And the default is false, okay? So when the install event is called, I can do self state dot install equal true, like this, okay? So for example, if another event is called, that is, for example, the start event, I could say here, if self.state.install, okay, if that's true, then
Got it.
okay, like that, okay? And if not, just to complete the thing, we can put here self unit status equal block status, and we say
Okay, got it. It's to ensure that the state of the events get stored, right? And then they could be used by each other, right? This is the intent.
exactly. That's the whole point. But it's important that you know that, for example, if you have one charm that has scaled out and there are multiple units of the same application of the charm, the state is not shared between the different units. For that, what we have are peer relations that are relations between the different units of the same application, and there's something that I'm going to explain just after this session, that is relation data. So there's some data that you can write into the relation, and this will make some events happen in the different units, and the different units will be aware of the data that was written into the relation. Okay, just to to make that clear. Okay, I'm going to. I don't know if I have made some spelling mistake or something here. Or
I understood. Got it.
So
Got it.
I went back to the previous state of the charm. Okay. And basically, right now, what we are going to do is we are going to deploy this. Okay. So we are going to deploy it as it is. So this is the state that you need right now in your OSM. You need to have the Magma orchestrator installed and or deployed and in a ready state. Okay, so make sure that you have done this and that you have only this network service instance and nothing else, only this. If you have something else apart from this, please remove it with OSM-MR delete and the name here.
Screen, David, we can't see your screen. It's black for me.
Okay. Everything is black.
Yeah, for me at least it is.
I can see the screen.
No, it's fine.
Okay.
Yeah, sorry, I zoomed out. I I probably zoomed in too much. Got it.
Okay. Perfect. No worries. Okay, so basically, make sure that you have done that, okay? And there's one script here that I have put that for you, that basically have some commands there that will be executed. I expect all of you to have deployed the Magma orchestrator with the IP that you have assigned. That should be this one, okay? So if you do echo of this, it's this is the start of the IP, and then the last two numbers are your Hackfest tenant. Make sure that this command works for you, and that's and it's the IP that you used for the Magma orchestrator, okay? And basically what this is going to do is delete the network service descriptors that you had before. It will create and push it will build and push to OSM the descriptors of this folder, okay, these two, the VNF and network service descriptors. Then it will generate the parameters, the instantiation parameters for the VNF, okay. And here in the orchestrator IP address, it will be used the one here that you have, okay. Then we will create the network service. For that, we just specify the name, the network service, and the configuration file, and so on. Also, make sure that you have something here, okay? I'm going to paste it to the chat. But make sure you have a key there. If you don't, you can do this. You can do that and then press enter as many times as needed. Okay. So once you have that, we will execute this. Oh, I cannot hear you very well. Well, I'm going to execute that. Okay, this is doing basically all these steps automatically. It's important for you to only have the Magma orchestrator deployed and not anything else, because if you have a network service instance using this, then this will fail deleting and this won't be pushed, so you won't have anything ready. So any changes. Okay, so if you see here below, I switch to the Juju model that has been created for me. So if I do OSM-NS list, I can see the Magma A gateway with this, okay? And here I see that it's in a building state, and it has one ID. So the same ID has been used for the Juju model, okay? So if I do Juju status, I can see that the name of the model is the same that the name of the network service instance. Okay. Okay. So.
Sorry, David. I think we're having problems with OSM. At least some of us. For example, Kafka error.
Same here, Anna. Same here.
Okay. Okay. So. So you cannot deploy anything, or you don't have the orchestrator there?
I'm trying to delete another NS and it broke up. Now I'm trying to execute an OSM NS list and it says error 404. I don't know why. And something like that.
Okay, send me the logs in Slack, please.
Okay.
Okay. In my case, you can see here. Okay, with okay, just one sec. Okay, that seems an error in the OSM deployment to which I don't have access. So that's a problem. I don't know if Gian Pietro is in the call or Fabian, maybe. Yeah, I think Fabian is. Fabian, can you hear me?
Just let me check. I'm going to check the servers.
Okay. But I imagine this is not happen to everyone, because in my case, I'm just deploying everything and it seems to be okay, at least right now. So, okay, well, I'm sorry if you cannot continue. I'm going to at least explain some things in my deployment. So for all of you that unfortunately cannot deploy it, it's a pity, but at least you can see how this is working. Okay. So basically, there's this command. Okay. Oh, sorry, this command that, let me paste it in the chat. Okay, Okay, this command basically will show you the status, the UU status. Okay, so in this case, we see different things. We see here the applications. We have the units of each application and the machines for the units. Okay, so the one that is active is the Magma gateway. That is the proxy charm, and that is deployed in LXD. Okay, that's the proxy charm. And also we see here that there's a relation that is the proxy peer relation. That one basically is the relation between the different units of the of this application. Okay, we haven't implemented anything in this charm. That's implemented in the SSH proxy charm class that we inherit from. And this one, the inode B1, that is the native charm. This one, it says here manual. This is because it's manually provisioned. This means that the RO is the one that has deployed or create the VM in which the charm is going to live, but now the charm has been installed inside the VM. Okay, and well, this is taking a bit more time as usual. I imagine this is happening because of a lack of resources, I would say, because it's not normal.
David, if you can, what is exactly unit? If you can touch upon it again, unit. When you say unit.
Okay, yeah. So when we deploy one application, let's say we are deploying a database that is MongoDB. So
okay,
that is the application. We deploy one MongoDB, but that MongoDB application can have multiple units. For example, if we want to build a cluster of MongoDB, we may want to have 3 units, 3 different VMs or containers if we are in Kubernetes, of the same application, that is MongoDB. So everything acts as one application, but we have different units. And the good thing of
VDU and KDU, right?
Yeah, it doesn't matter. It's well, this is a charm concept, okay, but it works both in K8s and in normal VMs.
So,
okay,
it's something like a VNF is composed of many like VDUs, let's say. So those VDUs are equated against the units, right? So if we have to imagine something of that sort would be
kind of, but not exactly, because one VNF can have different VDUs. In this case, we have a VNF with 2 VDUs that are the inode and the Magma gateway, but those VDUs have nothing to do with one with another. But in the case of proxy charm, or sorry, of charms, one application or the units of one application share the same code and the same thing, so are part of the same application.
Okay, got it.
Okay,
thanks.
Oh, you're welcome, Fabian. I think something is happening because with the OSM instance, because okay, yeah, something is wrong with the machine, because this one is now down.
Are they using Which one is your number? Because I'm looking now at the tenant 6.
Let me. I don't remember the credentials I used for the Vim account.
No, but you are using the 56. Okay.
Yeah, but I think the Vim user I'm using is Hackfest. I think is the one that appeared in the scripts in the OSM packages. I don't know if that matters or no, but all the tests I did them with this tenant. Okay, well, just for you to know, this should be set to active. Okay, and that's the only thing that is missing. Let's hope that when we add the relations and so on, that it will work. Let's see if we can do something with the OSM instance. But basically, this thing was only for you to see how everything is deployed, how the charms are deployed, and so on, and to see that there's no currently any relation between these two applications. So now we will basically add the relation, and then we will deploy everything again and see how the relation is set and so on. And also for you to see, if I do UU-config of the application of the Magma Virtual EPC, I can see there that the IP of the VM. Okay, so I can go there, and the credentials are magma. Okay, so magma. Okay, and here I can do this. Okay, let me paste the command. Okay, and basically we see that there are no connected inode Bs to the Magma Virtual EPC. This is because right now the relation is not done, so the inode B hasn't been registered yet to the Magma Virtual EPC. So in the next session, hopefully we will be seeing that after implementing the relation, we will be able to see here one number, and that will mean that the inode B is correctly registered to the Magma Virtual EPC. So I think we are going to close this meeting now, and that way we can save 10 minutes and dedicate those to figure out what's happening in the OSM instance. So let's stop here, and we will come back in 40 minutes at 4 o'clock and at 4:30, sorry. Okay, and well, I don't know if it worked for you or not, but if it worked, but I don't expect that it has worked. You can please put there in the spreadsheet that the EPC deployment with charms and no relations yet you can put a yes there if it has worked for you. Just that.